In this video, would like to discuss another example where what if the mass of planet X is not the same as mass of planet Y, or we can say that mass of X is equivalent to 2 times the mass of Y, where m of X is greater than the m of Y. Two identical still satellite orbiting around the planet, and this time the condition is, what is the relationship of the distance between the satellite and the planet, the corresponding displacement, so this r over here, r of X and r of Y, what will be the relationship between those two, to make sure that f of g of X is the same as f of g of Y. So this time we want to make sure that the force of gravity between them are the same, okay? But since the masses are not the same, okay, planets' mass are not the same, so therefore we have to do something, and in our case is to adjust the distance. Since we all know the mass of Y is less than mass of X, therefore we can say that r of Y, so r of Y should be less than r of X, or the distance between planet X and the satellite should be greater than the distance between the satellite and planet Y. Or we can say r of X, r of Y, so this one should be greater, okay? We should make it greater because the mass is greater, and the mass is greater, we need to decrease or increase the distance in order to make sure that your force of gravity is correctly adjusted. So let us begin. Okay. Start by using the equation f of g, that is g m multiplied by m over r squared. So let us start with f of g, or f of g on X. So we can say that the force of gravity between planet X and the satellite is equivalent to g m of X multiplied by the mass of the satellite divided by r squared. Rx, you square it. On the other side, let's use f of gy is equivalent to g m of y m over r of y, and you square it. So far we don't have to change anything in terms of y on this side for planet Y and the satellite. The only thing we have to adjust here is your equivalent value on planet X. So we can say that f of gx is equivalent to g, and that is 2my over m divided by rx, and then you square it. So this will be the value of fg of x, and this will be the value of fg of y. Now, since we all know that these two values will be the same, fg of x is the same as fg of y, we can just equate those two, which will give us g 2m sub y over m r of x squared is equivalent to g m of y over m r of y, and then you square it. So far, if we look at our equation, the values of our equation, we can cancel our values right here. So g and g can be canceled. If you divide both sides by things that you can divide, okay, so let me just write it down right here. Okay. That's a little bit delayed. So if I want to get rid of g, I'll divide both sides by g. So let's divide it by g. So I want to get rid of g. I want to get rid of my, then I will divide again by m sub y. M sub y. Furthermore, I want to get rid of this small or lowercase m. So let's divide both sides by lowercase m. Cancel my m sub y. Cancel my g on this side. M and cancel here. M sub y. Cancel. M cancels. G is cancelled as well. So what is left is 2 over rx squared equivalent to 1 over r sub y squared. So that will be our equation. Okay. So that will be our equation now. So let's see let's figure out the relationship between r sub x and r sub y. So the distance of x. So we said earlier that r sub x should be greater than r sub y. By looking at this value, yes, it is. So let's cross multiply both sides. So we can say that 2 r sub y squared is equivalent to r sub x squared. So therefore, we can take the square root of both sides just to show the relationship between the distances. So now we can say that square root of 2 r sub y is equivalent to r sub x, or the distance between the satellite and planet x, or planet x and the satellite, is way greater. So let me just zoom out so we can see. Is way greater than the value of r sub y. So therefore, this is correct, as it shows over here. On this side of our solution, that r sub x is greater than r sub y by the product of square root of 2.